Hello there, Mr. Sutton here, bringing you the AB Calculus 310 Extra Practice number 5 solutions on derivatives of exponential functions. For this problem, all they're asking us to do is just take the derivative of this expression. So going left to right, we've got two different rules being used here. First off, we have a variable to a constant, x to the fifth. So for that, we actually have to use the power rule. So that's going to be 5x to the fourth. And then for the next one, we have an exponential term. So this is going to be 5 to the x times ln of the base, so ln of 5. And then let's see here, that ends up being answer choice D. It's a little bit out of order, but answer choice D. For this problem, f is a function given as 2 to the x cubed, and we're given some values of this in the table above. Now this is kind of interesting because this was a calculator problem, but they're still giving you a few values for free. I mean, you could have gotten these even without using a calculator. If the values in the table are used to approximate f prime of 0.5, what's the difference between that approximation and the actual value of f prime of 0.5? All right, so we have to find basically a rock and I rock here. To approximate an I rock at 0.5, using the table values, we have to find the average rate of change on the interval from 0 to 1. So that's going to be 2 minus 1 over 1 minus 0. So this is our average rate of change to approximate f prime of 0.5. And that's just going to be, let's see here, we have 1 over 1, so that's just 1. So what they're asking for now, the difference between this approximation and f prime of 0.5, so we're just doing 1 minus f prime of 0.5. And we're going to do that on the calculator now. Since I'm allowed to use the calculator, I'm going to enter this in my y equals. So there it is. And I could figure out the derivative of this thing. It involves a chain rule. It's actually 2 to the x cubed times ln of 2 times 3x squared. But just so I don't make any mistakes, again, since I'm allowed to use the calculator, I'm going to quit out of there, and I'm just going to use the derivative function of this thing on the calculator. And I also have to have that 1 minus thrown in there as well. So I've got 1 minus, and now I'm going to use my derivative function. That's math 8. So math, and then 8, option 8, derivative. We're going to do dx. I'm going to do alpha trace and pull up y1, because that's where I stored my f of x function. So now I'm taking the derivative of that, and I'm taking the derivative at 0.5. Plug that in. Press enter. That comes out to about 0.433. which gives me answer choice B. On this one, I'm trying to find the limit as h approaches 0 for this crazy looking function. Now the key on this one is recognizing that they're actually giving you the limit form of a derivative, although this isn't quite as ready to go as a lot of these types of problems are. So this is something that's essentially in limit as h approaches 0 of f of x plus h minus f of x over h form. But we're not quite in that exact form yet. To get it into the form we want, I'd like to make sure I don't have a 3h down here for one thing. So I'm going to factor a 1/3 out of this. And while I'm taking out a 1/3, I mean, these 5's in the numerator, I don't really need those to be there either. So I'm going to factor out a 5 in the numerator. And the x plus h term should usually come first. So let me factor out a negative as well so I can reverse the order of subtraction. So altogether, I'm taking out a negative 5/3. That's going to leave me with limit as h approaches 0 of e to the x plus h minus e to the x all over h. So a big first step there. Now that we've done this, we see that the original function, whatever the x plus h is being plugged into, is really just e to the something, e to the x. So my f of x is negative 5/3 e to the x, and they're essentially just asking me to take the derivative of this. We're finding the instantaneous rate of change, the change as the distance between 2 points gets infinitely close together. So derivative of negative 5/3 e to the x, well, that's not too bad. That's just negative 5/3 e to the x. So that ends up being choice C. On this problem, this is a little bit more conceptual. They're asking for which of the following functions is the chain rule an appropriate method for finding the derivative with respect to x. Okay, so on the first one, we have a function inside a function, a composition Our outer function is sine of x. The inner function is 3x squared. So the chain rule would be the way to go on this one. And they didn't ask us to actually find the derivative, but we could if we wanted to. For this next one, we have e to the x times tan of x. Now, since I don't have a function inside a function, I have a product instead. The product rule would be more appropriate here. So this is a no. Now, technically, you can use the chain rule on anything. I mean, if you take the derivative of e to the x, the outer function is e to the something, and then the derivative of the something is just 1. But they're not really counting cases where you're just taking the derivative of x, because, I mean, otherwise you would use the chain rule on everything. All right, so this last one now, we have a 1 over situation. So you could use quotient rule here. However, you don't have to. You could also think of this as 8x to the fourth minus 2x, all of it raised to the negative 1. So you could think of this as having an outer function of x to the negative 1 and an inner function now of whatever's in this denominator, 8x to the fourth minus 2x. In this scenario, you would use the chain rule. So chain rule would be an appropriate method for this one. Would it be the most efficient? It might be, maybe not. But they didn't ask if it was the most efficient, just if it was appropriate. So then it's going to be choices 1 and 3, so choice D. For this problem, I'm trying to find the third derivative of 3e to the negative 2x. So the first derivative, using the chain rule and multiplying by that derivative of negative 2x, which is negative 2, that's going to be negative 6e to the negative 2x, because we have 3e to the negative 2x times negative 2. Next, every time I use another derivative here, I'm going to be using the chain rule over and over again. So I'm going to be multiplying by this negative 2 derivative over and over again. So my second derivative then, that's going to be positive 12e to the negative 2x. And then third derivative, that's going to be negative 24e to the negative 2x. And that looks like answer choice A. For this free response problem, which is calculator based, I'm given that f is a continuous function defined on negative 1 to 8, and they gave me the graph up there. It's just 2 line segments. Then we also have 2 more functions, g and h. G is this weird radical function, and h is this other function involving an exponential. And also a trig function. Why not? So they're telling us that the k function, so let's just throw a fourth function in there. Why not? That's defined as k of x equals f of x times g of x. And we want k prime of 0. Well, since k is a product, we can use the product rule on this one. So we're going to have f prime of 0 times g of 0 plus f of 0 g prime of 0. And the g function we can use the calculator for, but for the f function, we are going to have to refer to this graph here. So let's write this out with something filled in for f, and then we'll use the calculator to figure out this g and g prime of 0 business. All right, so for f prime of 0, that's going to be the slope of the f graph at x equals 0. So checking that out, that's right here. We have a slope of 2. So this is really 2g of 0. And then f of 0, that's the actual y value at 0. That looks like it's going to be 3. So this is going to be plus 3 g prime of 0. And at this point, I'm going to do the rest on the calculator. So here I am on the calculator. I've entered my g function as y1 and my y equals. And I'm not going to bother figuring out the derivative and entering that as well, because I'm just going to use the derivative function on the calculator. Since I am just taking the derivative at a single spot, I don't actually have to write out explicitly what that derivative is. So let me quit out of there now. We've got 2 times g of 0. So let me do alpha trace and pull up my y1 that I just entered the g function in. Open a parentheses and put a 0 in there. Great. Now I have plus 3 times the derivative of g at 0. So for this, I'm going to math 8. There's my derivative function. I've got dx. I've got alpha trace y1 going inside the derivative. And then I'm doing that at the x value 0. And let's press enter and hope for the best. Comes out to about 2.598. So there's our answer for this one. For this problem part, we're defining the function m, so we have a fifth function in this problem now, defined as f of x over 2 times g of x, and we want to know what m prime of 5 is. So for this, we're going to need to use the quotient rule and then plug in 5. So let me set that up. We've got u prime v minus uv prime over v squared. I'll just write it out so we have a general format, but I'm actually going to use the box and ribbon to help organize this. So I've got my numerator, f of x, and the denominator, g of x, so 2g of x actually, and then the derivatives of those, which are, of course, f prime of x and 2g prime of x. Now, before I actually multiply anything out, I'm going to plug 5 in inside the box, and then I'll put it back together. So plugging in 5 to each of these. F of 5, what's that going to be? Well, this is the graph of f, so at the x value 5, we have an output of 5 as well, so that's 5. And then 2 times g of 5, well, for that I'm going to use this function over here. And I guess, this is a radical. I could just plug in 5 and use the radical. But let me get a decimal, and I'll just store it as a variable on my calculator. So recall that I already stored the g function as y1 in my y equals. So I'm going to do 2 times, and then I did alpha trace, parentheses 5, to do 2 times g of 5. And I'm going to store this now as a, so I'll do alpha a, enter, and that's about 9.592-ish. So I'm going to call that a from here on out. And then let's see here. Down here we've got f prime of 5. That's the slope at 5. So for that we look it up on the graph. So here's 5, and it looks like at that point we have a slope of, let's see, we're going down 2 over 3. So that's going to be negative 2/3. And then 2g prime of 5, well, now I've got to go back to the calculator, and I'm going to do 2, and then let's see, for the derivative, math 8, derivative, we've got dx. I'm going to do alpha trace to get y1. So I'm taking the derivative of y1, derivative of g, at 5. And before I press enter, I'm actually going to store that as a variable, or a letter rather, a constant. I'm going to store that as alpha b. And now I can call that up whenever I want. So that's about 1.8766. Cool. All right. So putting it back together now, I'm going to just use the ribbon to multiply and subtract this in the correct order. So I'm going to have negative 2/3 times a. So this is going to be m prime of 5 over here. Whoops. There we go. I didn't want to zoom in. So m prime of 5, we've got negative 2/3 of a minus, so going the other way, this is going to be minus 5b. So very nice to have that just stored as a and b. And all of that is going to be over a squared, which is v squared in this case. And let me just plug that in the calculator now. I could leave it the way it is, to be honest, because this is all constants at this point, or at least all things that we know the value of. But I do want to see what that decimal comes out to, so here we go. So here we are back on the calculator. I did fancy fraction, and then another fancy fraction for negative 2/3. We've got alpha a for a, alpha b for b, minus 5b up there, all over a squared, and that comes out to a grand total of about negative 0.171. So there we are. On this problem, they want us to find the value of x between negative 1 and 2, where f prime of x and h prime of x have the same value. So f prime of x, let's see what that actually looks like from negative 1 to 2. So we're looking at the graph now, and from negative 1 to positive 2 for x values, it's just a single line. So that means the slope is always going to be the same number, which we're going up 2 over 1, so that's a slope of 2. So on negative 1 to 2, f prime of x equals 2 for all x values on there. So we need to figure out where h prime then has a value of 2. Well, what is h prime? We don't know, but we've got h. So we're going to take the derivative of this and set it equal to 2. Now, I will end up solving this on the calculator, but in order to get credit for this and show my work, I have to show algebraically what h prime looks like before I solve that on the calculator. So going from left to right, and it's not that bad, derivative of 5e to the x is also 5e to the x. And then we have negative 9 sine of x, that's going to be negative 9 cosine of x. And again, we want to figure out where this takes on a value of 2 on the interval from negative 1 to 2. So let's solve that on the calculator now. So here I am back in my y equals, and I already used y1 for the g function. For the h function, actually this is the h prime function. I'm putting that in y2, and I'm going to go down to y3, and I'm going to store 2 in there, the horizontal line 2, because I need to see where these intersect. And just to make my life a little easier, I'm going to go up here and deselect the g function because I don't want to graph that. Window now, I'm going to be going from -1 to +2, and then let me do a zoom 0, zoom fit, so I can get a really good look at where these two functions are hopefully intersecting. So there's my h prime. It's some weird exponential cosine-y sort of thing. And there's the horizontal line 2. So I can see we cross right here, just that spot. Let me do second trace, option 5, intersect. And my spider's already about where it needs to be. So let me just do enter, enter, enter. And that gives me about 0.622. So there's my graph. There's my value. And we got it. For this no calculator free response problem, we've got the graphs of f and its derivative shown above here between -1 and +4. For the first task on this, they want us to find the AROC, average rate of change of f, from -1 to 4. And we've got another task as well, but let's do this first. So for average rate of change, we're going to be doing f of 4 minus f of -1 over 4 minus -1, or 4 plus 1. So we've got 4 plus 1 in the denominator, and now what is f of 4? Well, looking that up in the graph, that is the value 1, y value of 1. And from that we are subtracting f of -1, which f of -1 over here is -2, so we're actually adding 2. So that's going to be 3/5 for my average rate of change. Now the next task, for how many values of x in the interval -1 to 4 does the instantaneous rate of change of f equal the average rate of change of f over the interval? So we're basically asking, in how many places does f prime equal 3/5? Okay, well, this would be difficult if we only had the graph of f, especially because we've got this corner here, so we're not even guaranteed that IROC and AROC match up at all on this interval. However, they also gave us the graph of f prime. So we just have to draw the horizontal line 3/5 on this graph, like so, and however many times that crosses f prime between -1 and 4, that's going to be how many times AROC and IROC match up. So looking at the graph, we see that between -1 and 4, we're crossing 2 times, and that's it. So 2 times, just visually seeing that, and we're done. On this next part, they want an equation for the line tangent to the graph of f at x equals 1. All right, so we're going to use point slope for this. Y minus y1 equals m times x minus x1. Now, we already have the x value. That's 1. They gave that to us. But for y1, we need to know the y value at x equals 1. So f of 1, looking that up in my graph, that's going to be a value of 2. And for the m value, the slope, we need f prime of 1, the derivative at 1. So looking that up in f prime, at 1, we have a derivative of -2. Now just plugging all that in, we have y minus the y value 2 equals my slope that I just found of -2 times x minus the x value 1. And they didn't say we had to put it in a specific form, so we'll just leave it in point slope. For part C, we're asking for each of these two limits, find the value or give a reason why it doesn't exist. Now this looks like it's a limit problem, but if you look a little bit more closely, we've got f of x minus f of 2 over x minus 2 as x approaches 2. We have two inputs basically that are approaching each other. This is actually Leibniz's form of the derivative. They're asking us to take a derivative of the f function at x equals 2. So what is f prime of 2 then? That's what this first limit is asking. Well, f prime of 2, we have an f prime graph, so let's just look up the value 2. If I go to 2 here, it looks like my f prime value is +1. Okay, well, that wasn't so bad. Now this next one is asking about f prime of 3. So looking up f prime of 3, we see here that it's a whole bunch of nothing on the f prime graph. And also here, we have this corner. So any way you look at it, this does not exist because the f graph is not differentiable at 3. Or you could also say because f prime does not exist at 3. But either way, you could also mention that there's a corner at 3. That would also be helpful. Any of those explanations should prove why this derivative does not actually exist. For this last part of the problem, we're defining a g function as e to the x times f of x. We want to know g prime of 0. So for this we need the product rule, which I'll just write out here, u prime v plus uv prime. We don't get anything for writing that, but it's nice to have a general format to plug things into. So we're going to use a box and ribbon to organize these things. We've got u and v up here. That would be the factors e to the x and f of x. Down here we've got u prime and v prime. So derivative of e to the x is e to the x. Derivative of f of x is just f prime of x. So far, this isn't so bad. Now, I actually want to plug 0 into this function. So let me do that inside the box, and then I'll put it back together out here. So if we have x equals 0, e to the 0 in the upper left here is just going to be 1. F of 0, well, looking that up on the graph, that's going to be 3 apparently. And then e to the 0 again is 1. F prime of 0, we can look that up on the f prime graph. That's positive 1. So now just putting it all together using the ribbon, we've got g prime of 0 equaling 1 times 3 plus 1 times 1, which is just 3 plus 1. If you want to simplify it, you don't have to. It comes out to 4.